Hey guys, so we're on to our next video for chapter 15 with stats. Hope everybody's doing good. You're probably tired of hearing me say that, but I really mean that. I miss you. You're probably tired of hearing me say that too, but it's true as well. So let's get a move on. In our first video, we had talked about what the variables are that we're looking at, that we have y hat equals a plus bx, and we're utilizing that to predict for the whole population of mu sub y equals alpha plus beta x. We talked about conditions and hypotheses. Then the next video, I did a speed lesson on confidence intervals and significance tests, but in reverse order of what I just said, but I'm not re-recording this video. This one, now we're going to talk about what is S. Well, you know how in our previous videos, we're saying that we're saying that A predicts alpha and B predicts beta, and y hat predicts mu sub y. Well, S actually estimates sigma. So S is talking about the standard deviation of the points about the line. So let's pretend this is my LSRL, and these are my points scattered around the line. Well, the way that we measure how points are scattered around the line is we look at residuals. So it should make some sense that S is talking about the standard deviation, the average variability of the points around the line. Well, that's kind of like standard deviation of the residuals. So if we were to add all the residuals together, all those distances, but we have to square them first because the positives and the negatives would cancel each other out. Square them, add them together, divide by, hey, look, those are our degrees of freedom, and take a square root. That's how we're going to get the variability of the points around the line. The smaller S is, that means the points are closer to the line. The bigger S is, the points are more scattered around the line. So, all in all, we are never going to actually by hand calculate S. Like, there might be a problem in your assignment. Screw it, you're not going to do it by hand. You're going to use your calculator. So if you're wondering, how do I get S? Well, you have to have data in L1 and L2. And then you either need to run a confidence interval or a sig test. So I'm just going to do stat, calc tests. They're all the way on the bottom. I'm going to do a Linreg t-test, and this is with my manatee data. L1, L2. Remember we were testing to make sure that the slope was positive? Hit calculate. If you scroll, there's S. Done. You would only be asked to do it on a calculator. You aren't going to be asked to do it by hand. You can also find it if you do your confidence interval. So the t-int, all of that should look good. There's your S. So that's talking about the variability about the line. We're 4.27. That's kind of low. So that means that our points are really consistent around the line. In terms of what do we need to do with all of this, what will a problem look like? Well, you'll find out in your homework. But one of the great things about chapter 15 is that you really are not going to be doing a lot of calculations by hand. A lot of what you guys are going to be asked to do is to be able to read a table. So I'm going to I'm going to go to in my book an example I'm trying to find a page and I apologize, right here, page 900. So page 900, I'm going to zoom in just a little bit. You guys have your books at home. This again is page 900. So I just wrote my book in ink. I'm powerful. So this is an example that actually starts a few pages earlier. And so what I want you guys to identify, you're going to be given the line. Notice how IQ is in place of Y hat. You have A and B and X. The Y and the X are going to be in context words. But if you guys were to take a test, which I still don't know how we're going to do all of this, we're just kind of getting through things, I would probably white that out, and you'd have to go find your equation by typing in your data. Also, when you guys look at the table, the coefficient, these are your A and your B. The constant is always A. When it gives you the context word, it's B. Here's S, that estimates sigma. We just walked through that. Here's your standard error of B. That's been in the formula for significance tests and confidence intervals. So that's the standard error of the slope. This is the standard error of the line. That's something different. I love how they circle this. We ignore this part. Truly, we don't give a crap about it. We need to find standard error of B from a printout. We need to find A. We need to find B. So that's kind of nifty that that information is provided to us. You'll also be given t-scores and p-values, but quite often those things will get whited out. Your t-score is the t-score from a significance test, and remember that that will match to a p-value. The smaller the p-value, the stronger the evidence against H naught. So if this p-value in this example is below 0.05, you would reject in favor of HA, which would probably be stating that we believe there's a positive correlation between how strongly an infant cries and its IQ at age 3. So I'm going to walk you guys through another printout, and I know it's out of context, but hey, look, I just magically turned the page on page 902. When we look at constant and coefficient, that is A. When we look at the context word in the coefficient, that is B. S estimates sigma. Your standard error of B is right here. So if by chance, oh no, what did I just do on my screen? I have no idea what I just did. Oh, that scared me. Okay, I don't know if that recorded it, but it just went to a split screen. I don't want that. So my book's going to be crooked so I don't bump that again. Let's pretend that we need to do a significance test. So I'm going to do H naught beta equals 0. HA beta greater than 0. If you're wondering, how do I know? Well, the words in the problem will tell you. Test if there's a positive or test if there's a negative. Positive would be greater than, negative would be less than. Test if there's a relationship and they don't talk about positive or negative, that'd be not equal to. So this is a positive slope. All right, here's going to be my t-score. We're going to do B minus 0 divided by the standard error of B. Well, B is the context word, 0.008569. Minus 0 divided by the standard error of B. It's that easy. If you're ever going to be required to use the standard error of B, you have to be given the standard error of B. You're not going to calculate it. I can't even remember if it's in your packet, but if it is, I don't remember, which means you aren't going to calculate it. It's not that important. So that would give us a t-score. I'm going to calculate that t-score really quick. I'm going to cover things up. So if we did 0.008569 minus 0 divided by 0.002456, hey, look, that's my t-score. That's my t-score. If we were to take that t-score and the degrees of freedom, and on this problem, trying to find the degrees of freedom real quick, let's just roll with it. If we were to take this problem and we would go to, I don't know, let's say 14 degrees of freedom, and we would take 3.4. I don't have a 3.4, but I'm in between these two. My p-value is crazy low. That's how this works. So you guys can do this. You can totally do this. Take your t-score, take your degrees of freedom, find your p-value in your t table. You guys can do this. That's how these tables work, and that's how nifty they are. If you needed to do a confidence interval, so I'm going to turn the page. I'm going to find another printout. If you needed to do, oh, come on, baby, zoom in. Zoom in. Please zoom in. We'll make it work. So if we needed to do a confidence interval on this problem, so I'm just going to start writing. B plus and minus t star times the standard error of B. Got it. So in this problem, yes, I know it says beer is move on. 0.017964 plus and minus. Hey, let's see if that's the right t star. Don't get too excited. The standard error of B. So that is 0.002402. On this one, Our degrees of freedom is 16 minus 2, which is 14. This is not your T-star. Guys, we got to go into the back table. We're going to have 95% on the bottom, and I'm going to come up to 14 degrees of freedom, 2.145. That's how we would get the information that we would need to fill in from a table a confidence interval. So that's it. That was a lot, and I'm sorry. And it was so foolish of me to think that that last Monday that we had together, that I could have gone through this in that amount of time, considering it was just an overwhelming day of what are we going to do, what's going to happen, nobody has answers, and how is this going to work? Well, this is how it's going to work. And I still don't have a lot more answers, but at least I know how this is going to work. We're in this together. You guys can do this. YouTube is amazing. Khan Academy is amazing. You guys are amazing. Find ways to help each other. Let me know how I can help you. I'm sorry this video was over 10 minutes, but it was the best that I could do. You guys will let me know if you need me to do another walkthrough step-by-step entire problem. But I'm going to stop on our videos for now because I'm already afraid that I've overwhelmed you. I think we're all overwhelmed. I know I am. But we got this. We're going to be okay. All right. Take care.